will design a memory system with how we connect a memory with a microprocessor under different scenarios. Okay, can you see the screen now, Munib? Munib,
Yes, sir. Yes.
okay. So how is the memory? You know the memory. So memory contains it's a memory chip on the left hand side. So a memory is actually a chip that stores the data. Okay, so it has four inputs. One input is the address. Address. Can you see on the left hand side? Address. Then there are other inputs: CS, OE, WE. These are the inputs. Okay, these are the inward arrows. Okay, so if you see the signal M is the width of the address bus. It's the width of the address bus. What is W, Munib? Munib,
Yes, sir.
what is W? What is signal W represent?
So data lines.
Which width of the data bus? It's always written on the right hand side. Can you see in the right hand side? If you see in the right hand side, okay. So here, can you see here?
Yes, sir. Yes.
Okay. So actually, if you look at here, so it's the width of the address bus. Then you have a width of the data bus. What does CS stand for?
Chip select.
Chip select. Okay, we want to select. OE stand for output enable. WE stand for write enable. Okay. Okay. Now we see that this memory this memory contains 2 to the power m locations. 2 to the power m location and each of size W bits. So this memory stores the data at 2 to the power m location, each of size W bits. And we can only access one of these locations. We can only access one of these locations. And this location will be determined by the address bits. So now in the scenario, there are two scenarios. Now we have a chip select. Can you see here? Chip select.
Yes, sir.
Okay, so we have chip select. So there are two possibilities. Chip select is 0 or chip select is 1. When chip select is 0, so can you see on the left hand side? So chip select is 0. This implies that the chip is disabled. We cannot perform a read or write operation. We cannot perform any read or any write operation when the chip select is 0. Now, if you see on the right hand side, if the chip select is 1, so the second possibility is that the chip select is 1. When the chip select is 1, now there are further possibilities. It depends upon the signal OE and WE. Now, OE is a 1-bit signal, W is a 1-bit signal. So there are four possibilities. There are four possibilities. When OE and W is 0, 0, when OE W is 0, 1, when OE and W is 1, 0, and when OE and WE is 1, 1. There are four possibilities. Okay. So the first possibility, when OE is 0, output enable is 0, and W is 0, when the write enable is 0. So it means that the memory will not perform either a read operation, not a write operation. So there will be no operation that will be performed on the memory. So there is no read operation and no write operation. We cannot perform any operation on the data. The second possibility is this: when OE is 0 and WE is 1, so it means that now it's a write operation. When it's a write operation, so actually what will be the direction of the data? The direction of the data will be inwards to the memory or outwards to the memory. G Munib. Hmm? Munib?
Sir, inwards to the memory.
Yes, isn't it? Direction. Can you see the arrow? Hmm?
Yes, sir. थोड़ा छोटा सा है लेकिन नजर आ रहा है.
Yes. So this like can you see the so in this case the direction will be inwards to the memory. So this in the right operation the direction will be inwards to the memory. Okay. Now the third possibility, when O is 1, it means output enable. The output memory will enable its output, and W is 0, so it means it's a read operation. So in this scenario, the direction of the data will be output from the memory. So actually, the data is bidirectional. Either you can perform a read operation, either you can perform a write operation. for a read operation, the direction will be the output to the output from the memory. Okay, so now this is also, can you see that it is in the read operation, the direction is now. When OE is 1 and write is 1, it is an invalid operation. Invalid operation. It's also, this is invalid, and you being as a designer, you should avoid this possibility when OE is 1 and write is 1. Everything is clear, Munib? Any question? Any question?
Clear, no questions.
Okay, all these slides are available on the Google link, so you can also see the slides. Okay, so now we will see now an access example. Now we see an access example. So, we already studied in the previous slide that this is the memory chip, and it can store tourist for M locations. How many locations is storing tourist for M location? Each of W bits. So now for this, we take a very small example. We take a very small example where M is equal to 3 and W is equal to 4. So how many locations will be stored then? How many locations will be stored? Munib?
Eight.
Yes. So the memory will store 2 for M. So it means that because M is equal to 3, so it will store 2 for M, that is equal to 2 for 3. So it will store 8 locations. Can you see on the right hand side how many locations are there? Location 0, 0, 0, 0, location 1, location 2, location 3, location 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 locations. It stores 8 locations, and the size of each data item is 4 bit. Can you see in this arrow? Can you see the arrow? This one. So the data is 8. Okay. So we are storing 8 locations. The first location 1, 2, 3, 4, 5, 6, 7, and 8. So it can store 8 locations. Okay. Now the first possibility. When M is equal to 101. When M is equal to 101, so it means we want to perform an operation on 101. But when the chip select is 0. So when the chip select is 0, what does it imply? Munib?
What will happen?
Hmm?
Chip select 0 है तो कुछ भी नहीं होगा सर.
No, there will be neither a read operation nor a
Alright.
write operation. There will be neither a read operation nor a write operation. So it means because the chip select is 0, so actually you cannot perform any operation on the data. Even you provide an address. Okay. So what's the next possibility? Now the next possibility. The next possibility, when the address is 101. When the address is 101, M is equal to 101, because it's a 3-bit signal, chip select is 1. OE is 1. What does OE stand for? Anybody answer? What does OE stand for?
Output enable.
Output enable. And write enable is 0. So it means it's a read operation or write operation?
Read operation.
It's a read operation. And which location we want to perform a read operation? At which location?
101.
101. What is the content of that location?
011.
0011.
0011. So it means if you see on the right arrow, so the arrow is outward or the arrow is inward?
Outward.
The arrow is outward. So the arrow is outward, and we are reading the location 0011 because the address. And actually, how many locations are there in memory? If you see this figure, how many locations are there in memory?
8th location.
8 locations. And how many locations can we access from memory? How many locations can we access?
Sir, 8. Sir, 8.
No. We can only access one location
At a time. Okay.
at a time. Yes, you're right. Yes.
Okay.
So at a time we can only access one location. Very good. So at a time we can store,
Yes, sir.
we can access only one location. Who will determine that we want to access a particular location?
Sir, address lines.
Address lines. So the address lines will determine that whether which location to perform. Okay. Now think of another scenario. Don't think of the other scenario. Now when M is equal to 111, which location we want to access?
Last one.
The last
Sir,
one.
8.
Yes, the location 8, and actually it's the last one. Chip select is 1, O is 0, and right W is 1. So what does it imply? It is a read operation or write operation?
Right.
Sir,
Okay.
invalid.
Write operation. So in this case, we should also provide the data from the outside. We should also provide the data from the outside. So the direction of the data will be inwards or outwards?
Inward.
Inward. So it means somebody will provide this data. Maybe microprocessor will provide this data to the memory. So what will happen after this? What will happen?
सर वो लास्ट वाली मेमोरी में मतलब कि ओवरराइट हो जाएगा 001
Yes.
के.
So the last location will be overwritten and the new data will be 1110. It is clear?
Yes.
Clear. Okay. Very good. Now we proceed further. So now there are two sides, because now we are going to design a memory system. We want to connect a memory to a microprocessor. So there are two views of the system. One is the memory view and one is the microprocessor view. So now this is a memory view or this is a microprocessor view?
Memory.
Memory. This is a view from the memory. This is a view from the memory. And now we want to see from the microprocessor perspective to run. So if you look at microprocessor, so microprocessor has 8 address lines. How many address lines are there?
A.
Acha, in memory, the address lines was mentioned by which signal? You remember?
Sir, repeat करें.
In memory, the address lines was represented by which signal? What was the name of the signal in memory?
A.
No, in memory.
Read write bar.
No.
Sir, address lines.
Yes.
Address lines.
Yes.
Address line, sir. And
M. Address line was represented by M, and data lines is represented by
W.
W, sir.
So okay, now we have two views. One is the memory side view, and another is microprocessor view. So if you look at it from the microprocessor view, so the address line is represented by signal A. You got my point?
Okay. Sir.
And the data line
Yes.
is represented by data lines is represented by signal
D.
T. Okay. Which signal will represent whether it's a read operation or a write operation in microprocessor?
Sir, W. Read write bar.
Read write bar. Read write bar. So read write bar will perform. So it means that the address lines, now from the microprocessor view, we say that address lines is used to determine which particular location in memory will be accessed. Did you get my point or not?
Okay, sir.
Okay, so the data lines. So the data lines will show the direction of the data determined by the read-write bar signal. So read-write bar. So actually, whether we want to perform a read operation or whether we want to perform a write operation, this will be determined by the read-write bar signal. So if the read-write bar signal is 1, what does it imply? What does it imply?
सर रीड ऑपरेशन होगा और डाटा लाइंस की डायरेक्शन वो आउटवर्ड होगी.
इनवर्ड्स होगी कि आउटवर्ड होगी?
सर मैम
outwards.
No, for
सर
microprocessor.
मेमोरी टू प्रोसेसर होगी ना, इनवर्ड होगी.
So for microprocessor, it will be inward. Very good, very good. And what about for a write operation? Memory write
सर
operation?
आउटवर्ड होगी.
The outward from the microprocessor. So there are two views. Okay. And now there is one another signal that is called as AS. What does AS stand for? What does AS stand for? Anybody?
ये address के लिए check करने के लिए कोई.
So it means A stands for address strobe. So I'm writing it. So A stands for address strobe. A stands for address strobe. So A stands for address strobe. So address strobe. So there are two possibilities. When A is equal to 1 and A is equal to 0. When A is equal to 1, what does it imply?
सर सिग्नल जनरेट करेगा लाइक मतलब कि वैलिड एड्रेस है कि नहीं.
So it means that microprocessor has generated a valid address, whether this address is valid or not. When A is equal to 0, it means that address is invalid. So when A is equal to 1, what does it imply? That microprocessor has generated a valid address. When does microprocessor generate a valid address? When it will generate a valid address? When should it generate a valid address? Anybody may answer?
सर जो मतलब हमने रीड राइट डाटा उसको दिया है, मतलब कि वो के रीड करे मेमोरी से, अगर वो मेमोरी में एक्सेसिबल होगा, अगर मतलब कि रिक्वायर्ड होगा, अगर मतलब वो उसको पॉइंट कर रहा होगा तो मतलब वो 1 होगा, नहीं तो फिर वो 0 होगा.
Actually, microprocessor will generate a valid address whenever it will require some data from memory. Whenever it will want to perform any operation on memory. And what kind of operation it would like to operate on memory? ये बताएं. Read or write?
सर रीड.
It's also possible that it should also be a write. Write भी तो होगा ना, या नहीं होगा?
सर मेमोरी पे परफॉर्म करना है या
So memory पे perform करना है. So it can either be a read operation, it can either be
यस
a
सर
write operation.
राइट ऑपरेशन भी हो सकता है.
Right? It can be a read operation, it can be a write operation. So we'll also explain some examples. Some examples. We also studied in before. There are some examples. Microprocessor. Now let's assume a scenario. Let's assume a scenario that it is an instruction fetch. We studied this. We studied this in lecture 25. We studied this in lecture 25. And now I will determine that whether you have studied. So instruction fetch is a read operation or write operation?
सर रीड ऑपरेशन होता है.
Very good. Instruction fetch is a read operation. Okay, so we want to fetch some data from memory. Okay, who will point to the location in memory?
Sir, A.
A will point. Yes, A will point to a memory. But there is one register within a microprocessor who points to memory.
सर वो MBR आई थिंक था या
No.
नहीं.
There were two registers. One was MAR, memory address register.
MAR.
And there was also one register that is called as program counter. If you remember,
यस सर.
program counter points to a location in memory. If you remember. So actually वो लेक्चर भी रिवाइज करते हैं, उधर से क्वेश्चन आ गए तो फिर बड़ा मसला हो जाएगा. So okay, so now we have different register within microprocessor, that is MAR, which is memory address register, or program counter. Now we have instruction fetch. So in instruction fetch, what should be the value of AS?
वन होगी.
sir.
AS. And what will be the value of read write bar?
वन होगी.
1 होगी. That's
वन
a
होगी.
read operation. Instruction fetch is a read operation. Instruction fetch is a read operation. Because instruction fetch is a read operation, so actually the value of read write bar will be 1. Okay, what will be the address lines? The address lines A be loaded with the contents of what? MAR. What is MAR?
Memory address register.
Memory register. And this memory address register will be loaded with which address?
सर जो सर हमने रीड करवाना है ना एड्रेस लाइन का.
Address line पे रेड करो, लेकिन program counter address. I told you again
यस
before.
सर.
Is program counter. समझ आई बात या नहीं आई?
यस सर.
Okay. What about data lines? What will data lines contain?
सर वो मेमोरी MBR में मतलब कि
No, the contents of the memory at location specified by address.
यस.
Actually, it's a read operation. So it means that it will perform a read operation. At which location it will perform a read operation, which is specified by an address lines. Okay, and
Yes, sir.
that value will be read from memory and will be available on which lines? Data lines. Am I right or not?
राइट सर.
Okay, just simple. Like if you see in this example, when address is 110, what will be the contents of the data bus?
सर 1000.
100. So that's the point. Now in this case, the address line is 110. So it means the address lines will contain 110. The address lines will contain 110. And what will be contained under data lines? जी बताएं बेटा. If it's a read operation. What will be the contents of data lines? If the address is 110.
So 1000 होगा ना?
Yes, 1000. So this is the same. So in this case, this is the same thing. The content of the memory which is specified by address. Okay. Now what about instruction decode? Let's say microprocessor wants to decode the instruction. During instruction decode phase, will microprocessor require any memory operation or not? I'm asking a simple question. जी बताइए बेटा.
सर नहीं.
Does not require any operation. Good. Microprocessor does not need an operation from memory. So what should be the value of AS address stroke?
Sir 0.
Address stroke will be 0 because microprocessor does not need an access to memory. And all the values, whether read write bar, this signal will be ignored. This signal will be ignored. समझ आई बात या नहीं बेटा आपको?
आगे सर.
Now, we want to store some data in memory. Now there is another scenario. We want to store some data in memory. We want to operate. If you remember, we already studied in lecture number 25 that there are different phases of execution of instruction. Different phases. What are different phases of execution of instruction? Do you remember the instruction phases? जी बता सकते हैं कोई? मुनीब?
सब पहले तो इनपुट के लेंगे ना मतलब.
No. There are different phases of an instruction execution.
Fetch, decode,
Fetch.
execute,
Very good.
operand store.
Operand store, yes. So there are different phases of instruction. So we have studied instruction fetch stage. Instruction fetch is a memory read operation. Then we have instruction decode phase. And instruction decode phase does not require any memory operation. Address store will be 0. Then we have operand fetch phase. If you remember, operand fetch phase. In operand fetch state, it also depends on the instruction. If the operand is a register, do you need a memory operation? Muneeb? मुनीब आवाज आ रही है बेटा?
सर आवाज आ रही.
Okay, so let's assume if we want to read some data from register, do we need a memory operation?
No sir.
We don't. In that case, address store will be 1. So now we are studying a scenario in which we want to store some data to our memory. Now this is an operand store to memory. If you look at this instruction, move $1056, comma hash $98. What is your source?
Sir $98.
So what is this addressing mode? Which
सर
addressing
ये
mode is this?
डायरेक्ट है.
No.
Direct.
No. Hash.
Immediate.
Immediate. Beta, it's very important for you to know the addressing mode. If
सर
you
वो
don't know the
नजर नहीं
addressing
आया
mode,
ना सर.
अच्छा
वो
ठीक
डॉलर
है.
नजर आ रहा.
No, if you don't know the addressing mode, you'll be in great trouble during your midterm. You will be in great trouble. ये मैं बता रहा हूँ मैं आपको.
नहीं सर.
Okay. Okay. So now, if you look at source operand, what is the source operand? Source operand, which addressing mode are we using for the source operand?
The immediate addressing mode.
What's the destination in this particular example? What is the destination?
$1056.
1056. What is 1056? $1056. What is this?
Sir,
Which addressing?
direct
which ad-
addressing mode है.
Which direct addressing mode? Where is the location? बेटा माइक बंद कर दे प्लीज.
मेमोरी में सर.
मेमोरी पे माइक बंद कर दे. माइक किसका ऑन है प्लीज? ठीक है. So the in operand is we are storing the operand in memory. Okay, so the destination is memory. So which value should go on the address lines? Which value we should go on the address lines?
Sir $98.
No, address lines.
$1056.
$1056 because we are using an absolute addressing mode, and in absolute addressing mode the operand lies in memory. whose address is the part of the instruction. And which address is the part of the instruction? $1056. So $1056 is actually the address, not the data. नहीं समझे बेटा?
Okay, sir.
And what is the
Yes, sir.
data? In this
$98.
$98 is the data. What will be the content of the data line? $98. And what will be the value of address row?
1.
1. What does it implies?
It is a valid address.
It's a valid address. So if we say, and okay, so read write var will be 0 or 1?
0.
sir.
Why it will why it's 0?
Right.
Why it is a right operation? Why it is a right operation?
मेमोरी में सर
So because we want to store in memory. Why? Because the destination is always on the left hand side. So on the destination side, if you look at this instruction, this is your destination in $105. This is 1056 is your absolute addressing mode. Destination is memory. समझ आई बेटा या नहीं आई?
आगे से
Now if you look at so direction of the data will be towards memory or from the memory?
towards memory.
So now let's assume this is the memory location, $1056. So this is the memory address. What does it contains? This location. What's the content of this memory? Old data. What will be the new data?
$98.
Am I right or not?
Right.
You got it or not? Please revise your addressing modes. If you don't understand the addressing mode, you will be in trouble. I'm telling you, please revise your addressing mode because these are the basic concepts of an assembly language program. Please revise your addressing mode at this point. Okay. Okay. Now we want to design a system. We want to design a system, and we want to connect this memory chip with a microprocessor. We want to connect with a memory chip with a microprocessor, and there are various scenarios. There are various scenarios in which we connect a memory chip with the microprocessor. I told you we have two different views. We have two different views. One is the microprocessor view and one is the memory view. Did you understand all these points or not? Okay. So in the microprocessor view, you have A. What is A? What does A stand for?
Sir, address line.
Address line. What does D stand for?
Data line.
What does M stand for?
सर एम भी मतलब वही वो मेमोरी के लिए होता है डाटा एड्रेस
M is an address line for the addressable location for a memory point of view. समझ आ रही बेटा या नहीं आ रही?
यस सर.
And what is W?
सर ये भी मतलब मेमोरी के रिस्पेक्ट से वो डाटा लाइंस होती हैं.
They are
Data line.
So yes, so we will study different cases. We will study different cases. When A is equal to M and D is equal to W, this is case 1. It is also possible when A is greater than M. Okay, we will study a different case. We will also study a case when D is greater than W. So we will study different cases. So now we will study a simple case. So the simple case is a very simple memory system design. When A is equal to M, so A is equal to M, what does it imply?
सर प्रोसेसर और मेमोरी की जो डाटा लाइंस है और एड्रेस लाइंस है वो सेम है.
Yes, very good. So it means the address lines are same when A is equal to M. And when D is equal to W, what does it imply?
डाटा लाइन सेम है.
Data lines are same. ठीक है. अब हम एक क्वेश्चन करेंगे. We will solve a problem. अच्छा. So we will solve a problem. The memory requirement of microprocessor is 4 kilobyte. ठीक है. And width of the data bus from the microprocessor side is 8 bits. So what does it imply? D is equal to 8. समझ आई बात या नहीं आई?
Yes.
Yes.
Memory available is 2 to the power 12 multiplied by 8. What does it imply? What is M?
12.
What is W?
8.
8. So I will see this. So memory available stories for M at cross 8, stories for 12 cross 8. So it means that M is equal to 12, W is equal to 8. Any question? Understood?
Yes, sir.
Very good. Okay. Now, if you look at the memory requirement of the microprocessor, what is the memory? What is the memory requirement of a microprocessor in our example? G.
So इंटरफेस करनी है प्रोसेसर से.
So what is the memory requirement? How much memory microprocessor requires?
4 kilobyte.
4 kilobyte. And we want to equal it with what? Okay, what is given now? What is given from the microprocessor? A is given or D is given?
D given.
D. What is the value of D?
8.
8. So okay, now we need to find what?
Sir, A find करना.
We need to find A. We need to find A. So can we write it like this? Okay, now 4 kilobyte is equal to 2 to the power 2 multiplied by 2 to the power 10 bytes is equal to 2 to the power A cross 8. Am I right or not? Any confusion? Any question?
No, sir.
2 to the power 2 is equal to 4. And what does 2 to the power 10 implies? Kilo. And bytes implies B. Okay? And it is equal to 2 to the power A. We need to find A. And what is the value of D here? What is the value of D here?
8, sir.
8. Very good. So we need to find A. We write it like this: 2 to the power 2 multiplied by 2 to the power 10. Byte is equal to 2 to the power 3. Am I right or not?
Yes, sir.
Because we want to convert it into bits. So 1 byte is equal to 8.
8.
Okay? Can we write it like this: 2 to the power 12 cross 8?
Yes, sir.
Okay. What is the value of A now?
12.
12. And in this scenario, what is the value of M now? And can you see
It's
from the
12.
right hand side? 12. So in this case, the address lines are same or different?
Sir, same.
Same. What about the data lines?
8. Same amount.
Data lines. Okay. Now we want to connect. Now we want to connect this microprocessor with the memory. अब समझ आ रही बात नहीं? What problem we want to solve?
Yes, sir.
We want to connect this. Okay. Now you have a USB slot and you have USB. What will you now do? Munib, it's a very simple question.
सर यूएसबी में को एसएस भी कर सकते हैं, उसमें वैल्यू लोड भी कर सकते हैं.
Actually नहीं USB में कर सकते हैं, लेकिन now we have to insert that USB into the USB slot. नहीं समझे आप बेटा? Memory chip is separate, microprocessor chip is separate. If you want to access the data from memory, you have to connect them. नहीं समझे बेटा या नहीं समझे?
Yes sir, yes sir.
Actually, that's the point. Now we need to connect microprocessor with memory, and now we will study how we can connect them. So now this is an example. So if we see from the microprocessor view, this is the microprocessor view. What is A?
Sir,
What is A?
एड्रेस लाइंस होती हैं.
What is A in this example? What is A in this example?
12 sir.
12. A is 12. What is D in this example?
8.
8. Okay, so how many address lines are there?
So 2 की power A into.
How many address lines? These are addressable locations.
सर 12 होंगी सर
12 address lines. So 12 address lines are indicated by A11 to A00. नहीं समझे बेटा?
यस सर
समझ गए सर.
And, okay, and what is the size of the data lines?
80007.
From 07 to 00. Let's assume that the size of the data lines is 16 bits. तो फिर हम कैसे represent करेंगे? How would we represent this? Let's assume the size of the data lines is 16 bits.
सर वो 0 to F हो जाएगा ना
No, 0 to F नहीं होगा. D15 to D00. Am I right or not?
हाँ D15
D15 to 00. Let's assume that the size of the data lines is 32 bits. Then
0 to
32 to 00.
D31 to D00.
30.
Am I right or not?
यस सर
And let's assume that the size of the address lines is 40 bits.
0 to 39
39 से 0.
Very good, very good. So that's the point. I wanted to. So I'm just giving a very small example just for elaboration. That's the reason. Now, if you look from the memory side, now we have a memory size, and in this memory side, we have this m is equal to 12. So m is equal to 12. We have 2 to the power 12 locations, each of 8 bits. So now we want to connect both systems. We want to connect both of them. Now this address strobe will be connected to chip select. मैं समझे या नहीं समझे बेटा?
यस सर
What does address strobe implies? What does address strobe implies?
सर अगर एड्रेस स्ट्रोक 1 होगा तो मतलब कि वो जो चिप सिलेक्ट है वो भी 1 होगी तो मतलब वो परफॉर्म करेगा डेट
Perform. When chip address strobe is 0, what does it imply?
डजंट परफॉर्म
So it means microprocessor does not need any data. Does not need any data. So the memory should be enabled or disabled?
सर डिसेबल्ड होगी
Why it should be disabled?
सर चिप सिलेक्ट उसकी 0 हो जाएगी ना
Why it should be disabled? It's the question is that why it should be disabled? This is a question.
The power save.
Very good, very good. For power saving, we need to disable the memory because we don't need any operation for power saving. Who said this? Very good. It's a very good answer. It's a very good answer. Okay. So now we will connect this address strobe with the chip select. Okay. So the address lines are same. So they are directly connected to the address lines of memory. Am I right or not?
राइट सर
Okay. So it means that A11 will be connected to M11, A10 will be connected to M10, A9 will be connected to M9. समझे या नहीं समझे बेटा?
यस सर
Okay. So the address lines are connected directly because they are same. So it's very simple. What about data lines?
सर W के साथ ही कनेक्ट कर देंगे
Very good. So it will be directly connected to W. So what does it imply? D7 will be connected with what?
सर W7 के साथ
W7. D6?
W6 के साथ
Very good. So it's directly connected. Actually, there are 8 lines, so actually we cannot connect all of them. So just for elaboration, we can directly connect them. What about read write bar?
सर ये दोनों को मतलब देंगे OE को और WE को
क्यों? अगर सेम होगा तो फिर अगर 1 1 होगा तो इट इज एन इनवैलिड ऑपरेशन. न समझे? When read write bar is 1, it means it's a read operation.
सर अगर वो रीड के लिए फिर वो
एक पे डैग देंगे दूसरे पे इन्वर्ट करके देंगे.
Very good. So can we write? Can we do it like this? Am I right or not? Because when read write bar is 1 and OE is 1, it means it's a read operation. So read write bar is directly connected to OE. And what about write enable? We invert. So now there are two possibilities. When read write bar is 1. So if you say, so there are two possibilities. Okay. There are two possibilities. So now we can say like this. So there are two possibilities. When read write bar is 1, read is 1. It means OE is 1. Am I right or not? What will the value of write enable?
0.
0. Okay. So it means that actually write enable is 0. So it means it will perform a read operation. But when read it's 0. What is the value of write enable? 1. To replace it will perform a write operation. Got it? Got it or not?
सर ये WE की नहीं है.
हाँ ये WE के लिए. So when read write what is 1? It's a read operation. OE usually be 1 because OE means output enable. Output enable is a read operation. So they are inverse of each other. They cannot be same. 0 0 they cannot be same at the same time. समझ आई बात या नहीं समझ आई? Because we studied 4 different cases. If you remember this, if you see this, okay. So OE is 0, write enable is 0, no read operation, no write operation. OE is equal to 1 and write enable is equal to 1. It's an invalid operation. याद आ रहा है या नहीं आ रहा?
Yes sir.
So for a write operation, WE should be 1 and OE should be 0. For a read operation, WE should be 0 and OE should be 1. समझ आ गई बेटा या नहीं आई?
सर आ गई.
Good, very good, very good.
सर मैंने क्वेश्चन पूछना था ये मतलब मेमोरी होती क्या है मतलब हमारी तो बिल्ट इन नहीं होती माइक्रो प्रोसेसर.
No. Memory is typically a separate chip. Sometimes this memory is inside within microprocessor and sometimes it is outside the microprocessor.
सर होगी क्या ये रॉम मतलब क्या होगा मतलब प्रैक्टिकली?
It depends on the memory technology. It can be in SRAM, it can be in SRAM memory, it can be a DRAM memory. It depends on the system that you are using. So if you are using a very small embedded system, when the memory is very small, so actually this memory is inside with the microprocessor and it is built with SRAM technology. But when we need very large memory, let's assume आपने कभी memory की chips लगाई है या नहीं? 256 MB की, 4 GB की और 8 GB की कभी लगाई है या नहीं लगाई?
की लगाई.
जिसका RAM की लगाई. So actually this is an external memory. So if we want to use an external memory, so you need an external chip. समझ आई बेटा या नहीं समझ आई? आपने पिक पढ़ा होगा ना, पिक पढ़ा होगा या क्या करेगा? एक होगी के अंदर इंटरनल में एक इंटरनल मेमोरी होती है, एक एक्सटर्नल मेमोरी होती है.
यस सर एक इंटरनल फिर रजिस्टर होते हैं एक्सटर्नल
इंटरनल भी मेमोरी होती है. ये हम ये अज्यूम कर रहे हैं कि नाउ वी आर यूजिंग एनी एक्सटर्नल मेमोरी एंड आई एम गिविंग वेरी स्मॉल एग्जांपल. देखिए मेमोरी साइज आजकल बहुत बड़े थे. 4 किलोबाइट मेमोरी आजकल होती ही नहीं है. Typically the memories available, the external memory available, they are in GBs. They are in GBs. So when it is in GB,
लेकिन वो
अच्छा अगर
एडिट में यूज होते हैं.
embedded में तो यूज नहीं होता. Yes, definitely. When it is in GBs, let's assume that the memory is in GB. So M should be more or less. ये बताएं. It's a question for you.
सर अगर क्या
और होगा सर.
When the size is in GB.
Yes, so data line तो बहुत सारी देते हैं.
Yes, the number of W will be high and M will be high. नहीं समझे बेटा? समझ आई बात नहीं? Because now in this example we are studying only very small memory of 4 kilobyte. हमने इस example में बहुत small memory की. Actually, if we want to increase the size of the memory, we need to increase M. If we want to increase the size of the memory, we need to increase W.
सर लेकिन वो मल्टीप्लेक्सिंग में आगे पढ़ेंगे वो तो फिर प्रॉब्लम खत्म हो जाती है.
वो देखेंगे क्या करेंगे. अच्छा अब ये चीज समझ आ गई नहीं जो मैंने आपको पढ़ाया यानी समझ आ गई ये चीज?
ये सर ये तो पहले लेक्चर में पढ़ी थी वैसे ही है.
हाँ ये समझ आ गई. अच्छा नाउ we will study a different case when the address lines are different and data lines are same. Now we'll study case number 2. Now we only studied a very simple case. In the previous example, we studied a very simple case when the address lines and the data lines are same. Now in this scenario, the address lines are different and data lines are same. When the address lines are different, what does it imply? Munib?
A and M are different.
A and F are different. Very good. In this particular example, A is greater than M. Okay. And what about the data lines?
Data lines are strange.
Data line is same. So, okay, so now there is another question. Memory requirement of microprocessor is now 16 kilobyte. In the previous example, what was the size of the data? बताएं बेटा.
4 kilobyte.
4 kilobyte. Now we are 16 kilobyte. Memory is same or different?
Different.
No, memory size is same. The memory available.
Yes, sir.
The memory is same. The memory requirement is different. So if you look at the right hand side, so memory available is 2 to 12 cross 8, m is equal to 12, w is equal to 8. Is the same as the previous example. The memory available is same. Okay. Now if you look at the memory requirement, the microprocessor needs it's 16 kilobytes. Can we write it like this? 2 to the power a cross d. Am I right? Munib? Munib? मुनीब कहीं चला गया मेरे ख्याल है. अब्दुल्ला बेटा आवाज आ रही है?
सर आवाज आ रही है.
अच्छा. So memory requirement is 2 for a cross d. Am I right?
Yes, sir.
Okay. Please mic बंद कर दें. थोड़ी सी इको आ रही है. This 2 to the power 16 is equal to 2 to the power 4 and kilo is equal to 2 to the power 10 bytes to the power a cross d. You can also write it to the power 4 cross to the power 10 byte is equal to 2 to the power 3. You can also write it like this: to the power 12 14 cross 8 is equal to the power a cross 8. What is a now in this example?
14.
14. It means a is greater than m. What is a? What is a?
Sir,
14, sir. 14, sir.
What is m?
Sir, 12.
12.
12. Yes. What is d and w?
8.
Sir, 18, sir.
8. Okay. And they are same. So it means now we are studying scenario number 2 or case number 2. Scenario number 2 when address lines are different. It means that a is greater than m and data lines are same. It means that d is equal to w. And both are same. It is equal. Now if we see, if we look at this problem, how many memory chips do we require? How many memory chips do we require? Do you have any clue? How many memory chips do you require?
Two. One more चाहिए.
Now let's see how many memory chips. So actually, the memory requirement for the microprocessor is 2 to the power 14 cross 8 on the left hand side because a is 14. And so it can be write it like this: 2 to the power 14 cross 8 is equal to 2 to the power 2 cross 2 to the power 12 cross 8. Am I right or not? Can you write it like this? 4 multiplied by 2 to the power 12 cross 8. The available memory is 2 to the power 12 cross 8. The requirement is 2 to the power 14 cross 8. So how many memory chips we required?
4.
Did you get my point or not?
Okay, sir.
Okay, so now we need 4 memory chips. So actually, if you look at this memory available, memory available, so the memory available to 12 cross 8 is equal to, initially it was 4 kilobyte. In the previous example, the memory requirement for 4 kilobyte. So this is equal to 4 kilobyte. नहीं समझे बेटा? इसका different तरीके से भी solve कर सकते हैं. So the memory available is 4 kilobyte actually, and the memory requirement is 16 kilobyte. So how many such memories do you require? नहीं समझे बेटा?
4 चाहिए होंगे. ठीक है सर.
Okay, so you can solve this problem from different angles. You can calculate the size of the memory, you can calculate the memory requirement of the microprocessor, and then you can perform a simple divide operation. Okay? In the previous example, the memory required was 4 kilobyte and memory available was 4 kilobyte. So if you divide 4 by 4, it is 1. So you need only one chip. आप समझ आई बेटा या नहीं आई?
सर आ गई.
ठीक है. Okay, now. So it means that now we want to design such a system. Okay. So the memory requirement in this particular scenario is 16 kilobyte, and the memory available is 4 kilobytes. So we need such 4 memory chips. So now we need to connect the microprocessor with these 4 memories. How do we connect them? It's a question. How do we connect them? अब समझ आ रही बात, ये नहीं जो the problem do we want to solve?
Yes, yes, sir, समझ आ रही.
समझ आ रही बात? Okay. Now if you look at this problem, what is A in this example?
14.
14. So it means that the address lines will range from A13 to A00. What is D?
0 to 7, sir.
D is 8 bits.
8 bits, sir.
07 to 00. Okay. Now we want to. So the first thing is very simple. What we will connect? We will connect read-write bar to OE1, OE2, OE3, and OE4. Simple. Am I right or not?
Right, sir.
Okay. Read-write bar will connect to OE because OE stands for output enabled. What about inverter of read-write bar?
Sir, right enable.
राइट एनिमल सेम सेम वेरी सिंपल, यानी जहाँ पे यहाँ पे याद आ रहा है ना, रीडर पर हमने ओई के साथ कनेक्ट किया था और इसका
Yes,
इन्वर्ट
sir.
कहाँ राइट एनिमल. ये तो समझ आ गई या नहीं समझ आई?
Yes, sir.
ठीक है, इट्स वेरी सिंपल. सो इट मींस वी विल कनेक्ट दिस. Actually there will be many connections. That's the reason that I'm avoiding this connection here. So there will be many connections. So now the data lines are same or different?
Sir, same. ये भी सभी के साथ connect हो जाएंगे.
Same. तो ये सबके साथ connect हो जाएंगे. This data lines will be connected to all the outputs of memory chip. It will be connected to memory chip 1, memory chip 2, memory chip 3, and memory chip, all memory chips. Okay. And every memory chip has 8 outputs. So D7 will be connected to W7 of memory chip 1, W7 of memory chip 2, W7 of memory chip 3, and W7 of memory chip 4. Similarly, D6 will be connected to W6 of each memory. समझ आ गई बेटा या नहीं? ठीक है. Now if you look at the address lines from the microprocessor side, is 14 bits. And if you look at the address lines of the memory side is 12 bits. So can we partition this address line from microprocessor into 2 portions? Can we write it like this, A11 to A00? So if we see this address A11 to A00, how many bits are there?
So 12.
12 bits. So can we connect this directly to all this? समझ आई बेटा या नहीं आई?
Yes, sir.
So now A11 to A00, these are 12 bits. And the memory address lines are also 12 bits. They are same. We are connected. What about the most significant bits? Which bits are missing now?
12 and 13, sir.
Very good. 12 and 13 is missing. 12 and 13 is missing. So we need to connect it in some fashion. How can we connect them? How can we connect them?
So MSP के लिए मतलब
कैसे करेंगे? So now it means we need addition circuitry. So we need A13 to A12, that is 2 bits, 2 bits are remaining. Connect it to a 2 to 4 decoder. We connect it to a 2 to 4 decoder. So in this scenario, we need a 2 to 4 decoder. 2 to 4 decoder. And the address strobe will go to the enabled signal of 2 to 4 decoder. So when address strobe is 1, it means microprocessor has generated a valid address. When it is a valid address, so decoder will be enabled. When address strobe is 0, what will be the output of this decoder?
sir 0. मतलब
0,
nothing,
0,
sir.
0. No, 0, 0. No, 0, 0, 0, 0. The output of the decoder will be 0, 0, 0, 0. Okay. So now if you look at this example, there are 4 scenarios. When A3 at 1 is 0, 0. And A3 0, 1, so it means this. When it's 0, 0, so CS1, it will be connected to CS1. CS1 means that memory chip 1 will be enabled. नहीं समझे बेटा? What does CS1 stand for?
Address status.
CS1. CS1.
Chip select.
Chip select one.
Select. Yes, chip select 1. Okay. What does WE1 stand for? Hmm.
So
What does
right
WE
enable
stand for? Right
right
enable
enable
1. Right enable 1 of what? Chip 1. Okay. So chip select 1. Address stop is connected to here, so it's connected to chip select 0. So actually, so CS1 is connected to here, CS2 is connected here, CS3 is connected here, and CS4 is connected. अब समझ आ रही बेटा या नहीं आ रही? Hmm? So now let's assume a scenario. Let's assume a scenario when A13 and A12 is A13 and A12 is now we will consider a scenario now in this case. We will consider a scenario that insert. We will consider a scenario when A13 A13 is 1. ठीक है? So now let's assume a scenario when A13 is 1. A13 is 1 and A12 is 0. Is 1 and 0. What will be the value of CS1?
0
0. What will be the value of CS2?
0
What will be the value of CS3?
1
One.
1. CS3 will be enabled. CS3 will be 1. So it means the decoder only one output will be enabled at a time. So it means that 3 chips will be disabled. In this case, if it is 1 0, chip 1 will be disabled, chip 2 will be disabled, and chip 4 will be disabled, and chip 3 will be enabled. So which memory will now provide the data? In this particular example scenario.
फिर 3 enable है तो उसमें राइट करेंगे
Yes, it will perform the operation. Actually, which memory will be enabled? So in this scenario, only one memory will be enabled at a time. Only one memory will be enabled at a time. And which memory will be enabled at a time? It depends on the most significant bits of the address lines. It will determine on the most significant bit of the address lines, and the most significant bit of the address line will determine which memory will be enabled. When the most significant bits will be 00, first chip will be enabled. It's 01, the second chip will be enabled, 10, third chip will be enabled, and 11, the fourth chip will be enabled. And which memory will provide, it depends on this. And it also depends on the address drop signal. When address drop is 0, all memories will be disabled because it's enabled. So when the enable is 0 of a decoder, all the output lines of a decoder will be 0. So in decoder, when enable is 0, all the output lines will be 0. When enable is 1, it depends on the input. So if it's 00, the first is, signal will be enabled. If it's 01, the second will be enabled. 10, the third will be enabled, and 11, the fourth will be enabled. समझ आ गई बेटा या नहीं समझ आई? जी